This video is going to review rigid motion transformations. As we've reviewed in class, there are three types of rigid motion transformations. There are translations, which is a slide. There are reflections, which is like a flip. And then a rotation, which is a spin. So a transformation is the mapping or movement of a plane and all points of a figure on a plane according to a common action or operation. So the action or operation could be the translation, it could be the reflection or the rotation, but it's the entire plane moving. For today's example, our plane is actually going to be something called patty paper. It's like tracing paper, but it's called patty paper because normally you would use this to separate hamburger patties when you go to freeze them, okay? So that's all I'm using today. That is my plane that I'm going to be moving around. So a rigid motion specifically is a special type of transformation that preserves or keeps. So this word preserves means to keep the size and shape of the figure. So as I move this figure around on the plane, the size and shape is not going to change. And that's because I'm going to be performing rigid motions. So the transformation on this plane is going to be the trapezoid ABCD. It's got angles A, B, C, and D, and then side lengths AB, BC, CD, and DA. This little bar above the letters indicates that it is a line. So the first movement that I'm going to perform here is a translation or slide. So I'm going to go ahead and I'm going to place my patty paper over the original trapezoid. Now the line that I'm going to translate it to is down lower and a little bit to the right on the paper. So I'm going to be translating this entire image down and to the right. In order to do that, I'm going to take my patty paper and I'm literally going to slide the patty paper down. So I slide the patty paper down and then I'm going to slide it to the right and I'm going to have the original point match up with a new point. Now I've already traced this image on both sides of my patty paper. So now when I draw over the top of it, it's transferring some of the lead to my actual handout. When I remove it, I have now an image where I can trace it darker. And then I'm going to label. I'm going to label these points with these little apostrophe marks. Now these apostrophe marks are called a prime mark. And it just means that this was a duplication of the original image. So I've got point A and then point A prime, point B, and point B prime. I have point C, C prime, and then D and D prime. So D prime just means it's a duplication of it, okay? Now another thing to note is that the original is called a pre-image. The duplication is called image. This is the new image after a transformation. All right, the next transformation I'm going to perform is a reflection. And for a reflection, I need a line of reflection. In this case, I'm going to use line L. So I've got this as my line of reflection. And then what I'm going to do is on my patty paper, I'm going to line up my original picture on top of pre-image. I'm going to copy the line of reflection onto my patty paper because I need to know where to flip the patty paper. So now what I'm going to do is I'm going to physically flip the patty paper over. Okay, so it's a flip. And I'm going to line up that line of reflection exactly where I copied it over. Now what you can see is that I've created a mirror image. And that's basically what a reflection is, right? That each of these points are the same distance to the line of reflection. So for instance, if A is, let's say, 6 centimeters or 4 centimeters, it could even be, maybe we're not drawn to scale, right? So whatever the distance is from A to the line of reflection, A prime to the line of reflection is going to be the exact same distance. So now again, I'm going to copy over the tracing that I had on my patty paper, and it's going to transfer that lead onto the handout. Notice that my letters ended up a little bit backwards, right? And that is because after the reflection, the letter direction was flipped. So I'm going to call this one A prime prime. It is the second duplication, and so I'm going to put 2 of those little apostrophe marks. I would have D prime prime, B prime prime, and then also C prime prime. Okay, so that was a reflection. I flipped the patty paper over, and each point is the same distance to the line of reflection. They're just on opposite sides. Our final transformation is a rotation. So I'm going to go ahead and rotate this trapezoid 90 degrees in a counterclockwise direction. So I always need to know which direction my rotation is going. Sometimes I will have clockwise, right? So clockwise is going to be turning the same direction as a clock, but this one is going to be going counterclockwise. So I'm going the opposite direction of a clock. I also need a point because I need to know, well, where is the center of rotation or point of rotation? So for this particular one, my point of rotation is point O. So again, I'm going back to, I'm putting the original trapezoid onto pre-image. This time I'm going to copy my point of rotation. Now in order to go 90 degrees, I'm not going to use a protractor to measure that. There are times when you would potentially use a protractor to measure the angles. But what I'm going to do instead is I'm going to put kind of just a little plus sign down here where that point of rotation is. And I'm going to put an arrow showing that right now my arrow is pointing up. Now when I make that plus sign, it's kind of like the quadrants of a graph. And I know that anytime I have 2 lines intersecting like that, it should have made a right angle. And a right angle is a 90-degree angle. So after I turn and rotate, as soon as my arrow is pointing this direction, I know I've gone 90 degrees. Okay, so I'm going to show you that again. As soon as I turn, now I'm going to put my pencil right where that point of rotation is, and I'm going to literally take my patty paper, which remember this is my plane, and I am spinning it counterclockwise, and I went 90 degrees because instead of my arrow pointing up, it's now pointing to the left. Just like the other times, I'm going to copy over my pre-image so that I can transfer the lead onto the handout. Now that I've moved it, I can go darker here. And then I also want to add my labels. And as you can guess, this time it's going to be A prime, prime, prime. This is our 3rd duplication. And we do want to make sure that we're differentiating between each of these images, because even though the size and shape have stayed the same, the location of the image has changed. So for each of these, that is why I'm using these labels to indicate location does change, but size and shape do not. Now, one last thing that we're going to note about all of these rigid motion transformations is that because size and shape did not change, these are all congruent images. Okay, so the word congruent means same size, same shape. Same size, same shape. And that is a special characteristic for rigid motion. There is one type of transformation that is not rigid, and that's something we'll be looking at later in the year. But right now, these are all congruent images. Congruent images also have something called corresponding sides and angles. Corresponding sides and angles. And that means that if I were to look at the length of AB, so I'm going to highlight AB, this length is the same for each of my duplications. So all of these yellow lines are corresponding lines or sides, okay? And they all have the same length. I can also see that angle B is a 90-degree angle. And so angle B prime is a 90-degree angle. And angle B prime prime is a 90-degree angle. And finally, on our rotation, it stayed as well. Those are all corresponding angles, and corresponding angles in this instance are congruent. So this is just a little bit more information for you about rigid motion transformations. Thank you.